Hey everyone, welcome to Austin LangChain User Groups Virtual Edition. It is March 7th to 2024. We're sitting here right at the start of South by in Austin. Thanks for joining us. Today we are going to be exploring LangGraph. LangGraph is one of the releases from the LangChain project. We're going to get into how it is, what it does. For all of us that are following along on the presentation. So we have a presentation that is uploaded to our repo. You can find it at this URL. Also, you can grab it in the QR code. If you're already browsing the repo, it's under Resources, Presentations, and then also LangChain 3720, 2024. If you are on the sessions, on our sessions interface right now. I believe you can see this. Cool. You can find this all the information to any of the labs that we're doing, any of the presentations that we're touching. One in the agenda. So if you click on Show Agenda at the bottom left here, you'll see the little topics that we're focusing on. So little information. Also, to click Show More, you can see direct links to the notebooks, the labs, or whatever that we're doing. Now, I also went ahead and put this on the right-hand side and copy time here. A little takeaways here, right? I'm going to go ahead and send you this email right now. This will be in your email box. So you have all the information you have necessary to follow along. Okay. Let me also give you a little tour of what we have here. So sessions, it's our collaboration interface that we use for virtual events. You have the ability to go ahead and contact your participants. Most importantly, we have a chat here. So if you have questions, any comments, if you can, log in the chat, say hi, sound off. See, get my toolbar in the way here. There we go. We have the ability to see some polls, and there'll be some polls that are popping up. Kareem or Ricky, you want to put together a quick poll? We can do that later. If you have any questions that we need to directly answer, if you have any questions, you can either post anonymously or put your name, put a question here. And what we'll do either throughout the session or in between the sessions, we'll go ahead and pull the questions and be able to use them to make sure we're going over what's important for you. There we go. Okay, next we have notes. Those are notes you can take away yourself, do whatever you want. This is transcribed, so we have the full transcription of the sessions available. Now, since you have access to the session, you'll get a link in your email that says access is memory, and so you'll be able to go through any of the transcripts here, any of the videos, and review them as need be. We don't produce any offers, and there's no timers. Okay. Also, if you up on the upper right-hand side, you can go ahead and switch this to audience, and it's going to break it down to the three of us. And I believe there was a way in your browser to make that even bigger. So, we have a poll. Have you used LangGraph? Yes. I'm going to go ahead and submit my answer. Okay, so that is going through the overview. Let me go ahead and switch back over to our presentation and we can continue. Okay, so again, if you want access to the presentation, it's available in PDF at that link. Also, of course, available in your sessions interface if you're seeing this live. Here's what we're going to go over today. I want to do a little welcome message. If you haven't been they haven't worked with us in LangChain user group before. Talk a little bit about that. We'll go over some light news and announcements. Then look at the fun stuff, which is fun. The labs using LangGraph. So we have two notebook-based labs to start you out with. That's Agent Supervisor Lab and a multi-agent collaboration lab. What's interesting, one of them, it's getting some really interesting behavior. I was just playing with it before we were launched here. And so we might have a chance to look at LangSmith and watch some of the traces on the back end. We're going to go over LangGraph RAG agent with Ollama and surreal DB. That is by Kareem. And then actually, I need to update this. instead of LM manufacturing bomb analyzer, we are going to go over decorators and custom tools. That. LangChain user group. We are local to Central Texas. We're in Austin, Texas, middle of South by right now. You can find us in multiple areas. One is the Discord. So we try to get on there and talk about whatever. Talk about our plans, coordinate. Encourage you to log on the Discord server. We keep our meeting notes, our labs, our presentations on our GitHub at Austin_LangChain in my repo right now. All the labs inside of here are Apache v2. So basically, you can do whatever you want with it. You just can't sue us for patent infringement. And any of the content, any of the slides, any of the images, it is what's called licensed Creative Commons attribution. So you can use it. You can take it for your own notes. You can take it for your own. You want to take some of this and teach some friends at work or school or whatever. Start your own meetup. You can absolutely repurpose it. Just give us a shout out. We track. We are on Meetup. So awesome LangChain AI group. And please, sign up there to get regular notifications about what's going on. We have a Twitter that'll do a last-minute announce for. We want to do. Excuse me for this. System. External headphones. Okay, cool. Sorry, we have a Twitter that I announce when we have meetings, usually last minute. So if you want to find out where that link is, we do record these sessions and post them onto YouTube at Austin LangChain. So we do host. Excuse me. We do monthly in-person meetings and workshops, as well as we started Hacky Hours, where we come to different bars and pubs and places around Austin, and we come together to hack on some code. It's really fun. We do have a monthly virtual meeting, which you're participating in now for those that are not in the Austin area, try to share what we learned. Our focus in Austin LangChain is to create an environment which is low stress for learning and sharing. This is a fast-moving project with AI. One of the coolest things that are out here. As some of our members like to say, we're not really trying to sell you anything. Not at all, actually. What we're doing is we're sharing what we're learning in the open as a group together. So the whole point is to connect with other early adopters, to share what we're learning, to disseminate tips and tricks if they're there, but most importantly, to learn, share, and grow together. Our code of conduct is very, very simple. Be cool to each other. Don't be gross. Right? Treat each other collegially. Anytime, even people at the top of our careers or at the beginning of our careers, anytime that we come back to learn something new, we all start at the same level. And so, treat each other with kindness and respect. Know that it's really hard to do this, but when we do it together, it's really fun. So, I want to give a moment to say thanks to our supporters for our in-person events, Meeting and Canonic. This is a beautiful law firm overlooking the capital of Texas at 1204 San Antonio. They've been so kind to let us use their conference room space, as well as this beautiful patio for our in-person mixers. I want to thank Keychain for food and beverage support. I want to, as well as organization, Charles, thank you so much for the help that you bring. I want to thank Always Cool Brands for the sessions platform that we're on today. But most importantly, I want to thank our contributors. So our contributors of code, our contributors of content, and our contributors of community. So let's talk about our announcements. Actually, I needed to update this. So the Hacky Hour went really, really well. We're posting a new one. I don't remember the date off the top of my head because it's not in my notes, but I will be posting it on the Meetup interface. And if anyone wants to pop through the meeting notes in the repo, I believe it's in our summary actions. So our RAG video for Ragify your Google Drive posted onto YouTube. The link's available there. If you want to review how you can use Google Drive and integrate that into your LangChain projects. Really interesting news, which has driven a lot of discussion, is Sora text to video. The preview has been released at openai.com/Sora. things that are really interesting in that is really it's the combination of the transformers model, so general purpose transformers, GPT, with diffusion models like stable diffusion, and the ability to effectively create object permanence and keyframe permanence across, like 10-second intervals across time, and effectively is bringing a whole new level of consistency to our generated videos. I'm really excited to see that available via API, but the preview where you can start to play with it and get an idea of kind of what the next level in the matrix is going to look like is available there. Also, really proud of the LangChain team, the LangSmith, which is a debugging tool, as well as a really workflow engine for AI projects, including LangChain, is generally available now. So it's really cool to see the team ship that code and get into production. So those of us who've been using the early access keys, we're there. So cool. A little bit. Let's now remind everyone that we want to see both your ideas for topics and any labs that you want to submit. So please hop on the Discord, say hi. If you have an idea for something that you want to see, post it there. Call for ideas, call for papers. If you have something that you've worked on, maybe at the hacky hour you want to show off, or something that you're working on and excited that you want to share, I'll get you on the docket, both either for the in-person or the virtual, and you'll have an opportunity to share the world what you're learning and kind of get yourself out there. Now, if you want to review our last meeting, again, the YouTube link is here. The Google Drive your RAG, and it's kind of fun. This was the start of how I got value from this project, was connecting in data in my Google Drive and throwing it into RAG interface. So some really cool instances here where if you want to run some labs, both in a notebook, but also if you want to Dockerize your stuff. Okay, so let's get to our labs in exploring LangGraph. Again, we're going to talk about our agent supervisor and multi-agent collaboration. We're going to run through 2 labs on this, and then we're going to hand it off and move away from OpenAI and use Ollama as a private agent, as well as some really cool integrations with surreal DB. And I need to update this, but we'll have a tools and decorators discussion, which is really important as we build our graphs. Okay, so everyone, if you can, please click on this link or click on the link on your side. Let me adjust the, there we are. On the agenda, you click in it. Wherever you want to click on it, you're going to come up with this agent supervisor, which I ran ahead of time. Okay, cool. Full plus, make this really big. Okie dokie. So if you're new to this, let me see which. So I had a, the link that you clicked on was directly into Google Colab. Now, if you're in the repo, and so if you're like github.com, McNamara, awesome LangChain. If you're in the repo, it's under labs. In this case, we're 104, LangGraph introduction, notebooks, and right here is agent supervisor. So if you can click on this in the repo, you'll see an open in Colab button. This will basically bring it into Colab, Google Colab. So for those of us that are new to Google Colab, this is just an online Jupyter notebook service that allows you to run these notebooks. Now, for those of us that have done any labs with us before, you're already going to be pre-populated here. Okay, so for the new people, I want to get you started on one thing or 2 things. Okay, so we'll go to, if you don't have your OpenAI key, you want to go to platform.openai.com. You want to actually log in. You want to go to API key is on the left-hand side, and you want to create a new key. So again, you sign up for this. They have some free versions of it, but just put your credit card in. You'll get billed by the penny pretty much. It's worth it. And so here you would put, like, I'm going to put a demo key. I'm doing a demo. Create secret key, and boom, press copy. Right? You're going to have this in your. Delete this and revoke this key because this is live and recorded. Okay, so now you're going to go ahead and click on the left-hand side of your, observe on the left-hand side of your Google Colab interface. You have a couple things. You have a table of contents, which is for the notebook. You have a search tool, which allows you to search through it, right? You can define variables here if you want. But most importantly, you have secrets and files, right? Files is actually files that are inside of this interface that are running in Google Colab. And keys is really, really nice because this allows you to, once you have it set up, you'll have this forever, right? You can define some API keys here. So we already copied our OpenAI API key. So what I want you to do is go add new secret, and then OpenAI _ API _ key. I'm going to go ahead and put like 200 here because I already have one. Now what I do is highlight here and paste it in, right? You can make it so no one sees it. Now this is the key I just revoked. So, I'm going to go ahead and delete that because if you see, I have one right here. Okay. Next, what I want you to do is go to tably.com and try it out. Sign in. Continue with Google. I'm just going to try it for work account because I already have one in my personal account. Oh, right outside. Okay. And then copy. And I think, maybe I just did it through work. Okay, so if you don't have an account, it's going to pop. It'll just give you a key based on a free account. So it's really easy to do. So take your key that is generated. It's like 1 or 2 clicks. Now what I want you to do now is type in tably _ API _ key. Paste it in. I'm not going to paste it because I figure I'm going to my live key. Yeah, and then paste for key. Oh, okay. I'm going to delete this because I already have it. With these are the 2 tools that we're going to be using today. Okay, and here's your link to Tablet. So that was a request from us. So what we want to talk about now is multi-agent collaboration, agent supervisor. There we go. Okay, so first I want to talk about the basics of like graph theory, right? So graph theory is effectively the ability to talk about a couple of items. You might hear about concepts like called a DAG a lot, especially in AI, and that's called a directed acyclic graph. And inside of a DAG or inside of a graph per se, you have the notion of nodes and edges, right? So what's a node and edge? So in this case, you as a user, maybe having interact with this. Okay, cool. So you have a user that's interacting with a supervisory agent. That supervisory agent is a node. Now there's 3 other agents in this graph that we're talking about, which is our agent 1, 2, and 3, right? And in the graph, we define edges, which are the connection points between nodes on the graph. You see, in this case, there is there's edges between the supervisor node and the agent 1 node, supervisor node and the agent 2 node, and the supervisor node in the agent 3 node, as well as between the user and the supervisor. Now, there's the notion of conditional edges, which is what makes a graph acyclic. So in that, your conditional edge may be that the supervisor can talk to the agent and the agent can talk to the supervisor, and they're defined explicitly in this case. So why is this important? Well, when using LangGraph, which is, and we'll see in our code, is that we're able to define the entry points to a group of agents and how they work together. We are able to define suites of tools. One tool might be the tablet tool, which we're going to play with, which allows you to search the internet via API, right? It might be the DuckDuckGo search tool, right? We have the access to different data sources, right? So an agent might have access to a different large language model or a RAG tool chain. So we can go ahead and use these maps of how our agents can talk to each other and what they're expected to do as a way to establish control over our agents. It's really, really cool. This is really kind of the great value that LangGraph provides. For those of us that have like a system or network administration engineering background or cloud engineering, you may recognize these almost as like Helm charts, right? Or even like Ansible configs if you're doing a low-level systems configuration. It's really interesting. It's kind of like an abstraction layer for our AI infrastructure. Pretty cool. Okay, let's go to the next one. So we'll go back to slide 1. Okay, so let's get to our agent supervisor setup. Okay, so we talked a little bit about the about graphs in general, right, and how graphs are implemented in LangGraph and what we're doing today. So in this code, again, us as a user, we're going ahead and interact with the supervisor node or supervisory agent. That supervisory agent is going to communicate to different agents, which have different tools available to them, and go ahead and execute a. What are we doing on this? I might be making finding some research about honky talks and awesome. So what I want you to do now, since you have your keys all set up, you have time to do that. What I want you to do now is press play on the first cell. So it's not authored by Google. Run it anyways. It's authored by the LangChain team, and then we've made some changes to it so it can run everywhere. So we're we're going to use a Python package manager to install LangChain, LangChain's OpenAI adapter, the experimental portions of LangChain, LangSmith, which is going to allow us to debug this, and then pandas for data frames, and then LangGraph. Right? I've already installed this. Actually, you know what? Now let me actually go ahead and okay, this should be all right. So if people have any issues, please pop in the chat, and we can make sure we can get you back on track. Let's see if we got a chat here. Cool. Or the Q&A. So in here we have our code that's pulling our keys in from Google, right? So this from Google Colab import user data pulls these keys in. It's really cool. So we're going to set our OpenAI API key, our LangChain API key, and our Tably API key, right? Press play here. Now, if we continue down here, we're going to actually create some tools, right? So I know I'm a little trying to think. If I lost it because I've already ran these. So we're going to go ahead and create the tools, right? So the one tool that we have available is a Tably search tool, right? So we're also installing Python REPL tools. So what are these things? So our Tably tool is basically a way of searching the internet with a paid API. And then our Python REPL tool is actually a tool that allows our agents to create code, right? So I want to point out a little warning here. While we're running this on Google's Colab instance, we're running this like on a Docker instance on a host up at Google. Not a problem. If our AI code escapes its jail and blows away the system, it is literally the same as disconnect and delete runtime. It's not a big deal. If you, however, are running this on your laptop, so say if you're running this inside of a VS Code and you want to use your .env, right? You uncomment this, comment out the other, and you can run on your own local box. I would highly recommend using a containerized environment for execution of notebooks or of your AI code. That way, if one of these contaminated LLMs come out and say root your machine or delete every file, you're protected from it. Okay, so we defined our tools. First, let me make sure hit that. Now we're going to define some helper utilities, right? So the biggest utilities here are going to be the ability to pass messages between each other, right? Or to have messages inside and have a scratchpad for what they do, right? We're going to give the agent itself is going to be a combination of the large language model, the tools, and the prompt we send it, and the agent executor executes the agents and gives it access to tools, right? Pretty simple. We're going to go ahead and define the function that we're going to create the nodes out of. So the nodes that we invoke, we're going to pass a human message and the output. And then we start to get really, really interesting here. So we're going to create our first agent, right? So we are going to create the supervisor, right? So you are a supervisor tasked with managing conversation between the following workers, right? The members, which is the researcher and the coder, right? Those are the two other agents that we have right here. So we have someone that's researching on the internet and then something that's coding on the internet, right? The prompt that we're given the user request, the respond with the worker to act next. So figure out who's the best agent, either the researcher to research information or the coder to display it, right, or write it out in this case. Each worker will perform a task and respond with their results and their status, and with finish, they'll respond with finish, right? So our team supervisor is a large language model node. It picks the next agent and decides to where to process, right? So it's really just an orchestration tool, right? We're going to define a function, right, which is the route. The description is how it can select the next role, right? Agree on. Next, we have a prompt where is basically a next action prompt. So if you played with any of their early LangChain-based agents, right, figure out what the next action is, or should we finish, right? We're going to use on the LLM, we're using GPT-4 1106 preview. And then we have our chain for the supervisor, right? So the supervisor chain is the prompt, and then we bind the LM function we created, and we figure out which route we're going to take to the next agent. So let's go ahead and construct the graph. Press play. Okay, so we talk about acyclic graphs, right? So the research agent, right? We tell it it's a web searcher. We give it the LM, which was GPT-4 1106 in the background, and we give access to the Tably tool. So you are a web researcher. The research node, right? We say it's an agent node, it's a research agent, and the name is researcher. Okay, now we have a code agent that we're defining in this graph. So let's create the agent again. The agent itself combines the LM, so GPT-4 1106, and then the Python REPL tool, which allows it to make code, right? So in this case, we gave it a prompt that we say you may generate safe Python code. Now, say you're running with like a LM that has been trained to be nefarious. Maybe the LM is trained to actually create unsafe Python code when it says to create safe code. So really interesting with what's going on now. So, but in this case, you may generate safe Python code to analyze data and generate charts using Matplotlib. Okay. In this case, then we create the node for the code, right? That's the name of coder. It's the code agent. And then we create a workflow. So we add node researcher as the research node, coder as a code node, and then supervisor in the supervisor chain. Now, here's a cool thing where we connect it together, right? So for each member, add an edge to the supervisor. Now, if you remember, when we're talking about, where's my picture? In this case, we're creating the connection between the agent and the supervisor, right? For each agent or for each node that's inside of there. We pass the conditional map that when they see finish passed, it is ended. Now we'll add conditional edges from supervisor in this conditional map, and we set the entry point as a supervisor. So going back to this picture, that's not my picture. Each time in this function we created, basically saying add a conditional edge to the supervisor each time we instantiate an agent, right? And then this one, and then set the entry point as the supervisor. So when we back to when I as a user interact with this code, the supervisor is how things come in and out of the graph. Okay, so we already pressed play here. We'll make sure again. Now let's invoke the team, right? So let's give it something to do. So for our team, code hello world and print it to terminal. Let's press play. So if we can see here, the supervisor, we entered at the supervisor, and our next, the supervisor decided the next thing, the appropriate agent to use was the coder, right? And so the coder said, it printed hello world. This has been executed, and output is hello world, right? So we used Python REPL, we wrote the code. So this is what came in, and the output is new line, hello world, right? Pretty cool. And then the supervisor observed the coder that was done, and supervisor said we could go ahead and finish this. Okay, so now we want to go ahead and do something a little bit more involved. So we want to pass into messages, write a brief research report on the cost and the history of Austin's honky tonk bar, the Little Longhorn. If people that have been to Austin, Little Longhorn is a beautiful little bar off Burnett. And let's see what it says. So the first thing it said, hey, I don't have information about this. Supervisor says, I need to talk to a researcher, not the coder, right? So let's see what's happening here. We're actually executing a lot of cells. Now, if we go over into LangSmith open, LangSmith here, and we go into our projects and agent supervisor, we should be able to see that we started, we identified our edges, we got to the supervisor established an edge to researcher. Now the researcher, if we go down here, is running a Lambda. Go to researcher on the left here. So it's saying write a brief research report, and it's gone ahead and should be seeing our tools here actually. Lambda, where are you? Agent executor, Tably search tool, there we are. So the researcher is connecting to Tably, and we're actually seeing it talk to its Scratchpad. We see the Tably, we see a tool call into Tably to go ahead and see what the Little Longhorn's about. It got a lot of information back from Tably, right? Which is really neat about Tably, which it passes all this stuff back. Now we'll actually see at the bottom of this that researcher that we're done. So let's go back to agent supervisor and see the Little Longhorn Saloon is a iconic talk. That is correct. The rich history within our cultural fabric, opened in '63 as Dick's Little Longhorn, and then the Little Longhorn passed to Miss Jenny Kalmbach in 1993, who she patched just recently. So we have a lot of information that we've been able to pass. So we went through a first run, and then the supervisor looked at that and said, take another look, right? And so the research went back and said, okay, this is good information that you come back. And what I want you to do is write your report, right? So we have a full report on the Longhorn inside of here. Let me make an easy way to show it in its interface. Oops. Let's see. I'm losing this in my, let's do like text editor or something. This is just not working. Text edit. Okay, we'll do demo as a step. So as you can see, what it is, it made a report for us. Okay, so now what we've done is we went through the ability for the user to enter with a supervisor to use agents, both a Python REPL agent for writing code, and then a Tably agent that had access to Tably search for writing a report. Now what I want you to do is, and I also want to thank the LangChain team for putting these together, which we've been able to make them easy for us to do cool things like hack them to write a report about Austin. Super easy. Okay, now what I want you to do is move on to our second example, which is multi-agent collaboration. So click on this link or dive down into our repo, but it's in 104 LangGraph Introduction Notebooks, multi-agent collaboration at IPYNB. Boom, I have that here. So what's different about single agent versus our agent supervisor versus multi-agent? Our graphs are more complicated, right? So if you have an agent that has a lot of tools available, the prompt engineering is kind of annoying, right? Because you have to train something to be an expert in many things, which functionally within LLMs makes them not good at any sort of thing, right? So in this case, what we're going to go over is breaking down um, agents into basically smaller functions, right? So the user is going to enter the researcher, right? It's going to pass a message to a router, right? And the router is going to figure out like what's the appropriate agent and tool to combine at once, right? We're going to pass them to our chart generator and researcher agents. As you can see, these are more complicated graphs. We have users to a node, we have a conditional edge to the researcher and an entry point. We have edges to router. We have, and then we have the router and edges to tools, right? And then have conditional edges that bring the tools data to the nodes, right? Edges that are back to the router, and then our edge to the user. So kind of interesting pattern that we're starting to see. Really is kind of like an instantiation of AI microservices, you might say, and in those services themselves are micronodes. It's kind of cool. See how things are going. So what I want you to do now is press play. We're going to again install LangChain or OpenAI's LangChain OpenAI's code, our LangSmith for logging, pandas data frame for storing data in a data frame. Think of it like a spreadsheet or a table. Our experimental code from LangChain, matplotlib for graphing, LangGraph to establish our graph start control, and then Python.m. You might be playing with having this output to files. So it should be loaded already. I had this set up to work with Google Colab by default. If you're running locally inside of a notebook on using like what's called VS Code, you can go ahead and just like comment this out, right? And then uncomment these bad boys. Anyways, this is for everyone using Google Colab. So go ahead and press play. We're going to again pull our OpenAI keys or pull our Tably API keys. And then LangChain API key is actually for LangSmith. So that's going to get it's going to stream our data to our debugging tool. In this case, I have it set to use a multi-agent, right? It's coming out or out of your LangChain key. So let's go ahead and create some agents, okay? So let's define a function here, press play. So in our agent, so helpfully assistance standard using user tools, answer the question. If you're unable to fully answer, it's okay. Another agent, another system with different tools may kick in, right? We'll help you where you left off. Execute where you can make progress. So let's stop getting in the loops. Right. If you or any other assistants have the final answer deliverable, prefix your final answer with final answer. Stop. The team knows to stop. You have access to the following tools, and we'll see the tool names that have access with the same system message. We're going to pass this in messages, right? We've seen before. Okay, so now let's define some tools. Press play. We have the Tably tool just here, and saying, hey, only pass about 5 results, so you don't overload it. And then we have a REPL, so write Python code, right? So we're going to define our tool function, right? So this is the Python REPL tool. It says use this to execute code. If you want to see the output of the value, you should print it out with print. This is visible to the user, right? And then if it works, say successfully executed. If it doesn't, failed to execute. Let's go ahead and create the graph. So the first thing we're going to do is define state. Here, what we're saying is it creates an object that's passed between each node, right? So we're going to pass messages back and forth. We're going to add messages to it. Let's define some tools. In this case, we have our LLM is GPT-4 1106. We have our research agent, right? So we're going to create the agent. We're going to bound it to the LLM that's above. We're going to give it access to the Tablet tool, right? And then we should say, and then we're going to pass a message to that agent said you should provide accurate data for the chart generator. So this agent is there to get data by using the Tablet tool, and it knows it's going to pass it to the chart generator tool. Excuse me. And then the research node is the agent research agent, and we're named a researcher. So we're defining that node in our chart, our graph. Our chart generator, we're going to create an agent again using GPT 4.11.06. We're going to give it access to the Python REPL tool so it can make code, and we're going to tell it that any charts you display will be visible to the user. Excuse me. We're going to define the node as chart node. We're going to pass it our agent node function, and then we're going to tell it it is the chart agent and the chart generator. So let's define some tools. Tools are independent nodes on our graph. Press play. Our tools are the total tools that are available are the Tablet tool and the Python REPL tool, and then we execute it using tool executor. So we'll define function tool node. This runs tools in the graph. It takes an in an agent action, calls that tool and returns results. We're going to pass state through messages, right? Last messages. Excuse me. Let's define some logic to here. Press play again. We'll define the router. Now, remember our router was the little diamond in the center. All of our agents go ahead and connect to it, right? The router itself stays at state in messages, right? And then it's basically going to call tools, right? And then it's going to end if the work is done, right? So let's go ahead and define our graph. Remember, the graph is how we connect these. We're defining how our agents or tools and us are able to communicate. So press play here. Define our workflow. It's a state graph that has agents data. Want to add node researcher. We want to add a node for chart generator and call tool, which is our tool node, and we define them up above in research node, chart node, and tool node. So we're going to add some. Let's say what can communicate with what, right? So our researcher, instead of the conditional edge, can talk to our router, right? And that can continue to the chart generator, right? And then it can continue to the chart generator, and then continue to any tools. So the researcher can talk to the router, and that router can pass this to the chart generator or the tools, right? We're going to go ahead and do the same for the chart generator. We can say, it can pass it to the researcher. We can continue on to the researcher, which is to call tool. We'll then do our conditional edge, right? So that each agent node updates the send field. The tool calling node is not, meaning this edge will route back to its original agent. Okay, so these are out and backs, right? So this lambda is the researcher and the chart generator are able to call tools, right? We're going to set the entry point as a researcher, and then we're going to compile the graph. Get up here. Okay, so now let's invoke what we just did. So we defined some very simple nodes with some very simple understanding. We defined our research node, we defined a graph node, we defined a router, right? So let's go ahead and enter this graph. Press play. So the message that we're going to pass to it is fetch Austin's gross domestic product growth over the past 5 years. Draw a line graph of it. Once you code, finish quickly. Now I put finish quickly in here. I'm going to actually just say finish because sometimes it gets caught in a loop. So let's go ahead and see what's happening here. So the researcher, it took our query, which is Austin, Texas GDP for the past 5 years. So it took that and actually kind of made it a little cleaner of a search. And then said, hey, use the Tablet search results, right? So from that tool, we have our results that a website from our Chamber of Commerce in 2021 posted our gross domestic product. The researcher says, hey, the search results provided some info, but not the exact GP values for 5 years, right? Okay, so let's go ahead and look for, we're going to use the tool to search for more, right? So it went to found census.gov and Austin State of Texas. It found this document, and it says that we've connected to the website. Cool. And it gives some the population statistics that we're getting, right? Or it's giving what's inside of here. And it said, hey, the last search didn't have all the data, so now we're going to FRED, the Federal Reserve economic data, right? So look, based on the latest search results from FRED, we have received the following data in millions of dollars, right? So we're starting to get actual data, right? Now, going down, we have the GP value for GP values, and it said the user has requested to draw a line graph of Austin's GDP in the next 5 years. However, still missing values for 2017. We will simulate this missing data based on availability growth rates. Okay, now we see we have a problem here, and it didn't get information from the JSON object. Let's press play again. Remember I said that it's finished quickly? It's been having some inconsistent behavior as it's been doing that. So let's go ahead and go back to our projects here, and let's go to multi-agent collaboration. And while that's running up here, we can look and see that what happened. So we called the tool, and tably something didn't respond how it expected. I don't know. But if we go back up here to it's currently running, let's give it a little peek what's going on here. And do a demo, lose a sale. So what happened earlier, right before when I tested this out, it actually graphed it out pretty easily. So let's just go ahead and try some. Finish. Change that back to finish, not from finish quickly. And on that note, are using active workflow. Okay, so we're gonna let that run. Let it run on your own. If it graphs out, it graphs out. It's pretty cool. It worked in our live version or in person, and we'll see if it keeps on going here. On this note, I want to prep everyone. Hey, Ricky. Do we see Kareem on the call? There's Kareem. Kareem, can you come off mute? Well, let's give a little go through some questions here. We got Q&A here. So and Kareem will prep for you to get ready. So LangChain, answer live. LangChain has been continuously evolving and introducing new quality of life. Quality of what improvements? QL improvements. What is the feature you like the most? Kareem, what did you mean by QOL?
Quality of life.
Oh, what do I like the most? This one right here. I actually see what's happening, and it's not just like bombing out. What other quality of life improvements do I like so far with the LangChain team? They put a lot of work into the docs. A lot of work into the docs. You know, early on in the project, you know, I applaud Harrison team for merging early and often and running a little hacker repo. We got a lot of momentum, but they've been releasing workable notebooks that we can easily expand and modify for our labs here and learn from. The documentation has been growing more consistent every day. The separation from LangChain experimental and LangChain core has been really great. Things have been a lot more stable. But we'll look back to the docs, and the other quality of life improvements has been the LangChain team's consistent work on updating blog to LangChain.dev, doing the videos. I feel like they've really listened when the community was like, hey, I'm having problems getting started, and really been stepping up. It's been making very much been easing my ability to learn and to get going with the project.
Yeah, no, I agree. The documentation has improved quite substantially with this new round of updates that they've been making. And they've gotten into a sort of like a cadence of releasing code samples and notebooks as they're releasing new features, which has been really great to sort of pick up and sort of really get familiarized with these new things that they're coming up with that have become so important when you want to develop applications using generative AI technology.
Yeah, I couldn't agree with you more. No, it's just what a fun, exciting time to be alive, and the fact that we're learning, with this project, we're literally at the cutting edge. It's really great to see both new research papers, which are implemented quickly by the teams, and then the ability to go through notebooks that are released by maintainers of the project, and to be able to modify them with just like we had here. These first two notebooks I went over were released by Harrison, and made some modifications so it would run within our interfaces here, and they made some functional modifications to it. This is allowing me to better learn the project and better grow in my abilities to handle Gen AI. So on this note, I'm going to kick it over to Mr. Kareem Lalani, and he's going to show us some really cool stuff with Ollama and surreal DB. So and being able to run a little RAG agent.
Awesome. All right. So this think of this exercise, and it builds on top of what Colin just demonstrated. It makes a few different. It takes a few alternate approaches, and I feel that that's a great way to sort of really see the breadth of what's possible. I mean, we are really only touching the tip of the iceberg here, but yeah. So in this agent, in this lab, we will be building a LangGraph agent. It's going to be a RAG agent, which means there's going to be some retrieval from a vector store involved. We will be using a locally hosted LLM. What I mean by that is you will not be connecting to OpenAI. You will not be connecting to any externally hosted LLMs. You will be instead you will have a local inference engine called Ollama, which is able to run Llama compatible open source models or open weight models. So in this case, we are using Llama 2. We have some other examples where we've used Ollama with models like Mistral. We will also be using this new, almost like cutting edge database technology called surreal DB. And so let me take a step back. Okay, this is Ollama's website, and you can get a feel for what's possible here. With you can go look at their models, and there's a whole list of models that are supported right out of the box, and these are all quantized models. The thing with Ollama is their goal is to make running language models locally really painless. So they've taken sort of this Docker-like approach where you have you run the engine on your infrastructure, and then you pull down models, like you pull down images, and then you run a container off of those. So in this case, you would run the model locally. You also have the ability to sort of, how with Docker, you can start with another base model and then make your own variations to it. With Ollama, you can do the same thing. You can start with the Mistral base model, but say you want to prefix preset a system prompt. You can do that through a model file, or you might have trained a fine-tuned adapter and you want to attach that, but not necessarily. Maybe since you're working on stuff, you don't want to publish it, but you're working locally. Well, you could create a variation of the model through this model file, which looks very it derives a whole lot from this Docker file approach. So what you're seeing here, this is very similar. So let me see if okay, let me not deviate from there. But You can get some information about what kind of model it is, how many parameters, what the stop parameters look like, what kind of prompt templates you'll be working with, and whatnot. The other tool, so the database that we'll be using is Surreal DB. It's a good question, Colin. Ollama recently released a preview version of their Windows client, so you should be able to run Ollama natively on Windows, and they're actively fixing, and improving the project. But you can run, like in my case, I run Ollama under WSL, but you have the option of running it both WSL and native. So SurrealDB is a multi-model database. What they mean by that is it's a database technology that can work as a document store, like your MongoDBs of the world. It can also work like a graph database and like Neo4j, but it does so in a way that sort of it works with the syntax that they have is very SQL-like. So you're working with almost novel technologies in interesting ways, but still working with a familiar syntax. So if you look at, let me just see, without spending too much time into this, there should be Surreal QL overview. Okay, maybe there's a better way to go about this. Let me not get too deep into this one. But the idea being that you can have tables which are similar to collections, or and you can do stuff like select all from table where ID equals this. So it's a very familiar syntax that is easy to sort of get behind. You can run it embedded in your browser. You can run it in WebAssembly. You can run it on a server. You can run it as a cluster. So they're doing really amazing things here. Worth checking out. The other technology we'll be using here is Hugging Face. Now, most of you would be familiar with Hugging Face. It's an online repository of models, AI models, not just LLMs, but AI models, data sets, and all sorts of stuff around AI. In this case, we will be downloading some data sets from Hugging Face, and we'll be using that in our application. We will be using a search tool. Colin showed how to use Tavily. In this demo, in this lab, you'll be using DuckDuckGo. It's very easy to set up. I mean, the nice thing is because of DuckDuckGo's philosophy, of being open, they actually don't require any. There is no API key. It's a simple wrapper around their search engine, and it just works. It's literally just one line of code to activate it, and then you can just start running using it. And lastly, this is optional, but we will be tying into LangSmith, and we'll walk through how it's going to look like. Okay. First step, we are because we are running this in a notebook. We will have to do a little bit of setup before we can dive into the code. First thing we'll do is we'll download the latest version of Ollama, and you can start following along. I've run this lab right before we started our session, just to make sure everything was still working in working order, and no issues. So you should be able to follow along. So first step is downloading the Ollama binary, the Ollama server, basically. And in the second step, we are running it. We are running it in basically Ollama serve is basically starting up the Ollama service, and it hosts its own API that you can then connect to and access the models and do generation and next token prediction, etc. We will now that once the model once Ollama is up and running, we will go ahead and download the Llama 2 model. This step takes a couple of minutes. It's downloading about 4 gigabytes of binary data, and the next line is basically just checking to see if everything is downloaded and it's ready. So Ollama list will give you the names of all the models that you have, a hash that goes with them, what size it is, and when was it last updated on your system. So say a week from now, Meta releases some updates to the weights of Llama 2. You could go ahead and you could do Ollama pull again, and it'll download the latest weights, and it'll just update it. So you won't have 2 copies of Ollama, of Llama 2, but you'll have basically just updated version here. Next step, we're doing something similar. We're downloading, we're actually running the install script for SurrealDB. So this is, again, coming straight from their installation, getting started docs. This will download the script and execute it immediately. Here it's saying that it's you're running it here. Of course, in your production environments, you will probably have a more a more resilient, more robust way of installing it. But again, this is for the sake of the labs. We're just running a script directly. Next thing we're doing is we are starting the server, the database server. We're providing the username and password, both root. Now this thing is different. I added it right now. It's not in the notebook yet, but you can put it. What it does is, if you don't specify this, then it'll basically start a Surreal in in-memory mode, which is great for testing stuff. But if you have to restart your session, well, you lost your database. Anything that you put inside is gone. So adding this parameter will give you sort of file-based persistence, and that's what you'll see on the left-hand side, that it actually created this folder. So if I run it again, it'll be able to read the state of the database, and it'll work from there. Next statement is, again, just to verify that SurrealDB is up and running as expected. I'm basically running a command, SQL command against their SQL REPL, logging in as root and checking the, and in the LangChain namespace, I'm issuing this command info for namespace, and that gives me this output. This output, all it means for us is everything is looking good, and we can continue with our with the next steps. We will install a few Python packages. Of course, we'll have LangChain community, LangGraph. DuckDuckGo search is needed for the search tool to work. Data sets is coming from Hugging Face. SurrealDB is needed for the SurrealDB vector store. Sentence transformer is needed for the converting, to creating embeddings that we will store in the vector store. Hugging Face up to download, it's a library that makes it easy to download stuff from Hugging Face. And python.env, this is so that we can load our environment file. So in the previous demo, you saw how you could use Colab's keys to sort of set up your environment variables. Well, this is sort of an alternate where, say if you're doing something, if you're running this application in a container, not on Colab, then you might run, this is one of the approaches that you might go about, where you will specify an env file, and you'll just load it. Next step, we'll set up our, we'll load up our environment variables. This file, this block will create a file. It'll write all of this to a test env file. If you have a LangChain API key, go ahead and put it here. You can give it any name for the project, and then you can set the value as true. If you don't have it, you can leave it as blank. What's pre-populated is sufficient for the rest of the demo. The only thing that you might not get to experience that way is the LangSmith portion for tracing. Once that is done, we go ahead and do the load.env. And what this essentially does is it reads this file that we've created, and it'll basically, within Python's context, it will inject those as though it'll make it so that it'll appear to Python that these were read from the environment variable. So you could do stuff like os.environment, environ, and then name, and it'll actually give you those. I did not set these in my environment variables, but .env sort of injects those values into the dictionary that Python uses when it's looking for those environment variables. This is just showing that, because I provided these it's showing that all of these were read. Really, like I said, for this exercise, you only need the last three, which are provided to you. Next steps, we're downloading a couple data sets. One is the all recipes data set from Hugging Face. It has recipes of about, I think, 2 million or so entries. And then the second one is a cocktails recipe. For this exercise, we will limit it to just first 5,000 entries. Although you can go, you should be able to use all of that. Same thing for drinks. There are about 6,000 drinks recipes. We are limiting it to just 5,000. And you can tell the total number if by the last entry here when it's doing the split. This is the total number of records that are in that data set, but we are only using 5,000. Similarly here, there's about 700 records. We are using 5,000. Next thing, we'll set up our, we'll basically load whatever we read from the downloaded from those data sets. We'll push it to our database in the vector store. In order to do that, we need to create embeddings because we will be doing vector searches. So similarity searches. So we'll use the Hugging Face embeddings. And for this one, I'm using All-Mini LM L6 embedding, but you could use any of the popular embeddings. If you have OpenAI API key, you could even use the OpenAI embeddings here. Next, we're setting up some variables for our to set up our database to data store. Surreal DB store is a wrapper around Surreal DB, which allows you to use it as a vector store within with LangChain. This is a community wrapper. It requires you to. Some of these are optional. What you do need to specify is, I think, the embeddings function. A lot of the other things, I believe, will have default values. Because this is, and then we'll just initialize it. This step is not needed for the first run. We're just deleting everything what we have. And then, so let me go take a step back here. This is recipes. Okay, so we'll go ahead and we'll start chunking stuff. Well, this chunking is not the same as chunking documents. We are chunking this because we're processing 5,000 records. We are processing them 1,000 at a time, just so that we can have a little bit of idea about how far along we are in the process. What we're doing in a loop here is we're going through each one of those 5,000 recipes, and then later we'll see that we're doing the same thing for the drinks recipes. And we are taking the text portion of the recipe, and we are creating embeddings, and we are pushing that into the vector store. By the end of this, sales execution, you will have had 5,000 recipes in. We'll initialize the second vector store for the drinks. Now, the structure for the recipes is slightly different. It actually has a single field called input, where it has the complete recipe. So it's a fairly straightforward process. If you look at the drinks data set, it actually has multiple fields. It has title field, class, garnish, and ingredients and recipe. So here's a handy function to sort of take all of those values and create a new input field, just to keep the name consistent with what we have with the recipes. And it's creating a single field with all of those values. It has the name of the drink, it has the ingredients, and then it has the recipe itself. Once we have that, we go ahead and do the same process. We process 1,000 at a time, and we'll push it to the database. After it's done, next we're just doing a quick similarity search to see if the data is, if it's able to pull similar results from the database. In this case, I just put non-alcoholic drinks with mango. It returns 4 results by default. You can override that by specifying the K value. Now, in this case, it's important to note that this similarity search is just that it's a semantic search. It is not trying to answer this question. All it's trying to do is looking at this this query that I provided. It's trying to find what documents in the database, in this vector store, are closest with semantic in terms of semantic meaning to this. So you'll notice that none of these are non-alcoholic, but they're all drinks with mango as an ingredient or in the name of the recipe. So, for example, here's mango punch. Here's mango Collins, apricot mango cocktail, mango cocktail. So our vector search is primed. It's ready to go. So this was all set up. Let's see, Colin, do we want to take a couple questions?
Yeah, let's do that. Okay, Q&A. Do we have any Q&A? Yeah, I don't see any questions so far.
Cool.
So, actually continue.
Okay, awesome. So this was all set up. Think of this as what, in a real world use case, this is your infrastructure that we've sort of gone through. We haven't started doing any LangChain coding yet. The closest thing that we've done is we've created a vector store. So surreal DB store is actually coming from the LangChain _community package. Right here, community vector stores. And embeddings is coming from community embeddings. And that's about it. So now let's talk about what we're trying to do here. So here's a graph that represents the LangGraph agent that we're creating. So we have access to 2 RAG databases. Okay, one which has the recipes for food items, one which has recipes for drinks. Besides that, we also have access to our search tool. This particular RAG agent, what it'll try to do is it'll look at the question that you ask it. It'll try to determine first whether that question relates to a food recipe request or a drink recipe request. If it's neither, then it'll defer to a web search. Okay. Now, if we are doing a web search, we'll always just return whatever the web search returns. On the other side, if it does find that it's a food or drink recipes search, it'll try to find those, matching, similar entries, and then it'll try to do another evaluation to make sure that what it found from those databases is actually answering the question that we asked. Now, we quickly saw, we just saw a few seconds ago that even though I asked it for non-alcoholic drinks containing mango, all the results came back with alcoholic drinks. So we're hoping that this retrieval quality check step is going to help sort of help with gauging the quality of the results. And we might then determine whether that quality is good enough or if it's not. If it is not good enough, then we will then defer to a web search, and then we'll return whatever we got back from the web search. So that's the agent that we'll try to build. So the way LangGraph works is you have a set of nodes that are connected to each other, in a DAG, like Colin mentioned. And nodes are connected by edges. A node can be connected to a single node through a directed edge, or it could be a conditional node where you might run some logic to determine, based on the output or based on the state of the graph, which edge to go. Now, that means that we talked about three things here, right? We talked about a node, we talked about edges, and we talked about state. Essentially, as soon as I push the question through the LangGraph, as it's going through each of these paths, we need to keep track of stuff. Otherwise, we would not know. For example, when I'm doing a quality check here, I also need to know what question was passed. Whatever output I'm getting out of the search, I need that to flow through here. So we need to maintain state. So that's the third component, right? The crucial component. We're basically starting with an initial state, and we are processing it through. We are running it through the graph, where it's sort of observing the state, it's manipulating the state as it pushes it through, and towards the very end, when we're done with it, we expect our final result to be somewhere in that state. Okay, so now let's proceed further. We'll start with, I mentioned the search tool, we're using DuckDuckGo. This could have very easily been Tavily. And that's what I really love about the way, the approach that LangChain has taken, is a lot of these components are hot swappable, even, if I can use that term loosely here, where you could change this with Tavily and it'll work. It'll still work. You could change the LLM from OpenAI to Ollama. It'll work. You might get different behavior because the underlying language model is different, but the application is still the same. It's still the same graph. It'll still look just like this. It just has a different processing engine behind each of these things. You could use a different vector database, vector store for SurrealDB instead of SurrealDB. You could mix and match. One data source could be coming from SurrealDB, other one could be coming from Pinecone, the other one could be coming from Chroma. One could be persisted to disk, other one could be coming from an external source. So all of that, and it's still the same application overall. So going further, proceeding along, we have these imports. Again, we are using we are importing LangGraph because that's needed for creating the graph. We will be using Chat Ollama from the chat models in the community. Prompt template, because we are not using a regular chat template here. We will be constructing a prompt template. We have some output parsers, string output parser and JSON output parser. Now we are using Pydantic from LangChain core, and we'll be creating a sort of simple model that we will use for schema validation for our outputs. And again, from Pydantic, we're using field validator. Now, let's take a step back here. I mentioned that we will be doing a couple different checks here. And because our output is generated from a language model in the first case, actually in both cases, or both of these circles are LLM interactions. We want to make sure that the output is always conforming. You do that by providing, by letting the, including in the prompt, hey, I am always expecting a JSON response. It works most of the times. Sometimes, depending on the language model, it might not work. The nice thing is, Ollama out of the box supports a configuration where all of the output that comes out of it will be JSON. And then we can use that with a little bit of Pydantic validation to make sure that it is always in that format. So we will construct our state. This we are using a type dictionary, so a question to keep track of the question. We will not change this question as we go through. It's just there for our reference. Context is where it'll if the graph goes through the retrieval steps, it will store the results of the retrieval in the context. Response is going to be the final response that'll come out of the LangGraph. That we expect to come out of the LangGraph. So this value needs to be set, because we will be checking this value after we get back the output from, we'll be checking the state at response. Steps is just a quality of life thing. Again, for debugging, we don't need this if you have LangSmith. But in this case, if you don't have LangSmith, you can still see the order of operations that took place. It's a very crude version. Quality is the step that we are, at right this check retrieval quality is going to be the that's where it's storing the value of that. It's actually storing the value out of the LLM, which we will then check in that step. Oh, didn't mean to do that. Okay. And next is just what are we going to do next? What are we going to do a retrieval, or are we going to do search next, if I'm not mistaken? Okay, in this case, again, instead of using a single chat Ollama instance that's talking to Llama 2, we have two. I mentioned that we need JSON responses in some step, for some steps, and we can use text response for the other step. So JSON response is going to be that for that one, I'll be using the JSON model, and where I need text generation, I will use the text model. They're both using Llama 2 under the hood, but the format JSON is what makes sure that Ollama will the output that I'll get back is valid JSON. Okay, now we will go ahead and put together some bits and pieces of the graph. First thing, I mentioned that we need to analyze the question, and based on that, we need it to output either food, drink, or search, which we will then use in our logic here to send it, to determine which edge to take to connect it to this different node. Okay, so in this case, I'm creating a a pedantic class called classifier output, which is going to be a single field called output, and it's going to store either food, drink, or search. This is this way I can conform using I can use Python, the pedantic library to make sure that that's it's conforming. Next, we'll create a prompt using the template. We're saying you are a request classifier. Look at the request below, and then classify whether it's food related or drink related. If it's not, then then respond with search. We are giving it sort of like a one-shot guide, and we're saying that we want the output to be JSON, and it needs to contain in this format. Inject the question here, and then the output will follow this. This is going to be our first LLM chain, review chain, which takes the review prompt, which we just described here. It'll feed it to the JSON model that we created here, and then it'll pass it through a JSON parser using the pedantic object that we created just above here. Okay, so that's our first chain. Some quick sanity test to make sure it's giving us outputs that we desire. First question is, what's the recipe of chicken biryani? Output food. That's what we were expecting, so that's great. Second one, I just put mango shake. I didn't even pose it as a question. And it says it's a drink. Okay, great. Third one, something that is not food or a drink, I just put weather. So it correctly identified, tagged it as search. Okay, great. Next step is our, going back here, is for this, the second step is to observe the outputs and then determine whether it meets the quality criteria that we have in place. And what's the quality criteria? We are saying that, you're a recipe reviewer. Look at the recipe that I provided and look at the question that I asked, and based on that, tell me whether it matches, if the response adequately answers the question. And a response should be a rating of true or false. Again, I could have chosen a better naming here, but again, this is, I just went with rating for now, and that's again a JSON chain, takes in the review retrieval prompt, JSON model, and then in this case, we created a different parentic object, which will have a Boolean field called review of true or false. Oh, I said rating here. Okay, good thing I didn't test it here. But cool. So then we start putting together other pieces. This is, so the way, again, going back to our graph, at every step, what's happening is we're passing the, some state in. The question becomes part of the state. It gets passed to this first node. A function is associated with that node that will take that state, do something with it, whether it's running a tool, whether it's pre-processing it, whether it's running it through an LLM chain. That's all part of that function. And what you'll do is you'll manipulate the state that comes out of it, okay, in that step. So going back to the code where we were, node functions. Okay, the first step is review query. This is, we are reviewing the question and determining the next action. Review query is going to review the question, and then we're expecting an output to come out of it, right? So that we are just going to store in the next variable in the dictionary in the state we have. And what we've done is, I mentioned, right, the steps thing. I'm just, for my own debugging purposes, I'm saying, okay, because this is the first step, I'm just going to initialize this list with a review query string in it. That way, when I look at the output, I can sort of trace along it. Second one is retrieve recipe rather, which is for the case when the question that was identified was a food-related question. All we're doing there is we're doing a similarity search against the recipes database. We are providing the question, and we're setting a score threshold of 70%. What it tells me is only give me the results that are really high quality similarity matches. I don't want, okay, here's the best I could do, and it's maybe only a 5% match. We'll take everything that we get back. We will convert it into a list, extract out the pages, the doc pages, page content, which is in the document structure that comes out of the retrieval. And we are storing the, let's see, we're storing it in the context. Yeah, we're extracting, we are mapping over that way. We're extracting the page content out of the docs, which we got here, and we're storing it in the context. It's a list. Next step, we're clearing it out because we don't use this. This is only needed after the first step, which determines which whether we are doing retrieval or we are doing search. So we're clearing that out. We are appending to the steps that we just now went through the retrieve recipe step. We do the similar thing with the drinks. If it's the drinks, then we search the drinks database, and it's the same step. Next step is a review retrieval, which is looking at the quality of the retrievals, and then based on that, it's determining how to proceed further. Okay. Just to keep it simple, what I'm doing is, if we have any values that came out of it, if we have a rating of, let's see, if rating equals true, then go ahead and do this. So only for those where we have a rating of true, we go ahead and look at that, and we just grab the first item, and then we go ahead and set the quality of true. Otherwise, we set the quality to false. and then we add a review retrieval to the states. Again, context is clear because we don't need to deal with the documents anymore. So we're just clearing that out. And the last step is the search web, where we're looking at, if you come into the node that is tied to this one, then we want to do a search. We are just invoking the search tool with a question, and we're shoving the answer in the response. Next is clear. There is no context at this step, and we are adding the search web. So these were the this is the logic tied to each node. Okay. Next, we have some conditional routing. For the review initial query, basically look at the response of the what kind of question it is, and then use that to determine what edge I'll take. Since the edge name is the same as so we're just returning the whatever is in the next property next in the dictionary in the state. Similarly, the retrieval quality, we are looking at the whatever the value in the quality is in the state. We are returning just that, whether it's true or false. In this case, it's going to be food, drink, or search. Now that we have all of that set up, let's go ahead and build the graph. It's a state graph which takes which uses this agent state as the state type. First node is review query, which is tied to the review query function. Similarly, retrieve recipe, retrieve drink, they're tied to their individual functions. Review retrieval is tied to the review retrieval function. Again, left-hand side is the name of the node. Right-hand side is the function it'll call when the graph is executing that node. Okay, and then search web is tied to search web. We are specifying an entry point to review query, so that's our that's where we'll say whenever we invoke the graph, that's where we want to start, which means as soon as you start this, it'll run this query. Then we are adding a couple conditional edges. For the review query, we will run, we will, at the output of review query, we will run this function, and then whatever output comes out of it, we will look at that output, and then we will determine what the next, what the next node needs to be. So if the output of the review initial query is food, then the next node is review recipe, retrieve recipe. If it's drink, then retrieve drink, and if it is search, then search web. We'll go ahead and add, for those, we'll add, for the retrieve recipe, it's a direct edge. There's no conditions there for review retrieval. After we have retrieve drink, we'll do review retrieval. Again, going back for visual context, these lines are edges. Okay, so in this case, after we have retrieved it, they all end up here, right? So the last conditional edge is the review retrieval. Whatever's coming out of that node is whatever's actually rather traveling through that edge will go through this function. And if it's if the value is true, that means the quality of the retrieval is good. So end it right there. We have the response already. Otherwise, go to the search, and search will always end be an end. We go ahead and do app workflow compile, store it into the app, and now we have our LangGraph ready. We have a few different tests here. What's the recipe for pineapple chicken? And let's look at the steps here. It went through review query. It determined that it was a food-related one, so it went to retrieve recipe, and then it did a retrieval, a review of retrieval. The quality was true, which means that what we got back from our retrieval was deemed as good enough quality, being answering, that it answered the question that we posted. So that's the answer. The response is baked pineapple chicken. We asked it for pineapple chicken, and we got baked pineapple chicken. So that's looking good. Second one, how to make a martini, goes through, it looks very similar. Review query, retrieve drink, review retrieval. Quality looks good. So it's the recipe that it found was one sip martini. It's got the ingredients, and it's got a recipe here. This question I came up with because I wanted to sort of see whether we can go through a path where we go, it's a food type question, but the quality of the retrieval was not good enough. So in this case, I asked, how to make chicken Manchurian with gravy. We got this response, but if you look at the steps, review query, it went to retrieve recipe, so we know that this was food. When it did review retrieval, the next was search web. That tells me is whatever we got back from the retrieval was not considered as a good quality output from by the LLM. So the quality was false, and that's why we went through the web search. Last one, I asked, okay, what's the weather in Kauai? Not food related, not drink related. If you look at the steps, review query, directly went to search web. Quality is none because we never did any retrieval, so there was no quality to verify. And we got, right, as of, when I ran this few minutes ago, looks like, it just gave me, okay, last update was March 1st. Yep. From last week. Actually, no, this is right. March 7th is the last one that it got back. Okay, yep. So there's that. Now, quickly, let me jump over to Surreal DB Rack. This was the project that I had set. For each one of those searches that I did, it created a LangGraph tree here. Remember the first question we had asked, what is the recipe of a pineapple chicken? First, so this was the input. This was a state that I provided. And this was what came out of it. The output state after it modified it. Why did it come this way? Because it went through the review step, and review said, okay, this was food related, and that's why this is the output. Next step was it retrieved the recipe, and it got back a bunch of stuff, right? It put all of those in the context because it found 4 items. It found pineapple chicken, these pineapple and rice casserole, and then based on that, it picked up, like I said, we short circuited. We just went with the first one. If you look at this one, okay, how to make chicken Manchurian with gravy. If you look at the first step, it said, okay, this is food related. Okay, great. Let's retrieve recipes. You look at recipes, it actually didn't find anything because even though it was a food related query, a list of 5,000, it did not find any search, similarity search that passed the 70% threshold, which is why this context is empty. And because there is no context, the review retrieval step actually said, you know what, this is not good. Let's go ahead and then it went to the web search, and it got back this result from the web search. And again, the last one was pretty straightforward. So yeah, that's the lab.
Okay, I'll throw a pull up here. We've played it before, whether it's surreal, Hugging Face, or whatnot, and we'll open the table. Does anyone have any questions want to add before we move over? Show my window real quick. And as we're doing my stuff, I want to kick it on over to. I want to thank you, Kareem, for showing how we can use local databases, local LLMs, how we can extend the function of surreal DB or use the extend function of surreal DB to make it easier to create effectively segregated vector stores in how and what we do, and use LangGraph, or actually LangSmith, to go ahead and take a peek inside of our application structure and how it's all operating. So really, really cool. And I love how I love your angles of using local LLMs. Today I was going and creating a custom GPT in ChatGPT, right? But ChatGPT was dumb today. It was only returning 10 items versus 25 or the 100 that I wanted. One thing I always like about Labs is that it has the ability to utilize these locally generated, or these generated models we run locally. So we can regain control inside of our application structures.
Absolutely.
Yeah, thank you so much. So on the note of control within our applications, I want to hand it off to Mr. Ricky Peruccio, and he's going to talk about decorators for LangChain custom tools, higher order functions. So Ricky, will you share your screen and take it away?
I can't hear. Ricky, can you?
Test. Can you hear me now? Okay, awesome. Okay, cool. Sorry about that, guys. Yeah, so thank you for that, Kareem. Your presentation actually ties very nicely into mine. Because you talk a whole lot about nodes, and you talked about basically agents interacting with state as they basically progress through like interacting with each other in the graph. So I just want to talk about basically kind of the nitty-gritty that is making this possible in LangGraph, specifically decorators for making custom tools, and then higher order functions for LangGraph agents to manipulate graph state. Cool. So basically just talking about Python basics, decorators, higher order functions. How many of you guys have heard of these before? So decorators, if you had never heard of them before, they're basically functions that wrap other functions. Usually, so you always see them when an at symbol, and like the function that is decorator, and it'll be above a function, and it will basically just modify the behavior of a function. It's pretty simple to understand. That's all it does. It just modifies the behavior of a function and returns another function with that function wrap. And here is an example. This is a decorator that we're defining here. We have a function here that we take as an input. Here is the function that we're taking as an input. We have here the decorator we're calling out above that function. And then we get back this wrap function with our decorator. And this is used to basically figure out how much time your function is taking to run. But it could also be maybe a decorator function to do memoization or caching or some kind of logging. It kind of helps you separate the concerns better in your code. So, you don't have to keep basically, I don't know, having a logger function in maybe a piece of or a module that like has no business with logging. And then we have higher order functions, which are a little bit more complicated than decorators, but they basically do the same thing. Actually, decorators are higher order functions. So all decorators are higher order functions, but not all higher order functions are decorators. So what they do is they accept other functions as inputs, arguments, but they could also either return other functions as outputs or return back some result, or basically, yeah, just modify the behavior. So it's a little bit more flexible than using a decorator. Here is an example. So here we have a function to filter profanity, and here we have basically a higher order function right here, define, that filters out, that applies that this other function here to filter profanity. To basically wrap, like return the filtered list of words that have no profanity, right? So this is kind of an example of how you can modify the output of a function, taking the function as input, the filter profanity, into this response transformation, and apply that to each, basically to each to the input that you provided. Kind of think of it like maybe in JavaScript you have these like built-in like map or filter functions or higher order functions, if you used that before. So here's like an example of basically a decorator used in LangGraph or LangChain. This is really, we really use them to quite simply define custom tools. Now, this is not the only way to do this. You could also do it with a base model class, I think it's called, which would have been interesting to tie into here. Yeah, so just talking about decorators here, the way custom tools work in LangChain, you will have this @ tool. So you import this from LangChain core, and you will put that above your custom tool. And then you have a doc string that basically tells the LLM how to use that custom tool. And this is kind of where your prompt engineering comes in. I kind of, in the previous lab, I was using I was doing like a tool that could traverse a network X graph, but the LLM would try to guess like the attributes that each node had. So I had to be like very specific of what attributes there were, and I put it on the prompt. And as soon as I did that, everything started working. So it's just like an FYI, you might have to be like very specific in your prompts when you do this. And speaking of decorators, these you will use in LangGraph by default. I think Kareem used the base, the other way to like define the tools, but basically here now we can move on to higher order functions, and they essentially these will be what how like an agent modifies the state, right? The state is like this ball that you're passing around from node to node, and essentially every time it gets passed to a new node or an agent node, the agent node sees what it's on in that state, and then applies some tool that you define that it can use to transform that state again. So this concept of transformation, this is all higher order functions. Like for example, here you see this on this agent node, you have this agent function, and we define here. Well, this now is a higher order function. Same thing for this action node that we're defining the function here. It said, and notice how we always pass the state here. That's the state that your LLM or agent is modifying using the LLM to basically reason and interact with the state. Same thing with this conditional edge here. You pass the state, should continue. Passing the state. Why do we pass? Like, how does it know from the state? Because the last message here will basically give the instruction, should continue or should I not continue, right? If I should continue, then I'm going to go back to the action node and figure out what to do next. Otherwise, I'm just going to stop. And this is another example of this that I kind of stole from Colin as he was presenting. He defined in his notebook an agent node that essentially just takes the state, takes the agent itself, an agent that you define, and then the name of the agent. And so here on the bottom, you see this research agent that is basically defining that agent node. And then research agent is defining the tool that agent node can use. And then we use this func tools partial that basically lets you run a higher order function with specific arguments always intact. So in this example right here, we have this agent param and this name that we have an equal sign here, basically saying this is always going to be a research agent, and this is going to be called a researcher. Then we pass in this higher order function here, agent node, and what happens is this agent and name will go into this higher order function, but the state will not be touched, right? Because the state is going to be manipulated by your agent. You're trying to just basically define the node that will be like what tools will this use, or what will be the name of this agent. But then the state is what your agent actually works with. So this is the way for your agent to basically manipulate your state. And then here's kind of an example of Kareem as he was presenting. I kind of took the screenshot because he did it a little bit differently. He defined these functions just like single-handedly. He did one function basically per agent, whereas my function here was kind of more modular. I could use it for defining a bunch of more agents. But here he's using these to basically do one agent at a time. And as you can notice, it's always taking a state object as input, so that the agents can interact with the state. That's pretty much all I got. Any questions?
I can have a comment. So one, I really appreciate how when you took in your talk, they'd gone through each of the notebooks that we've done. I learned so much from you as well as from Kareem. What a great way of taking the labs that we're doing here today and providing more context around the topic. So thank you.
Thank you guys. Yeah. It's been really interesting, like even seeing you guys going through your notebooks. I feel like LangGraph is kind of complicated to grasp, at least for me, because there's like all these functions that go in these other functions that go in these other functions, and they're so like nested, and just like following like, okay, what's happening? How are these functions going to other functions? How are my agents like manipulating the state? And just like looking at the patterns over and over again, just kind of like helps me drill it in my head. So that's kind of like the big takeaway that I'm getting here.
Awesome. 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 Well, I really appreciate it. Let me see. So now we have a little bit of readback. So in our polls, our first poll is, have you used LangGraph? So 4 people said yes, they've used it. 8 people said no. Interesting. Let's see the chat here. Ken says thank you. Wow, how can I get back to? I lost my ability to go through other polls. Well, thank you, interface. Anyways, okay, so some of the polls we're not able to get right now, but that is okay. What I want to make sure that everyone, there we go, everyone understands is that we thank you. Thank you very much. That you can, if you want to go and join us and learn together in the open, you can find us starting in our Discord. You can sign up for our meetup where we do our in-person and virtuals, our in-person stuff in Austin. Again, we're doing our virtual meetups as well as these really fun hacky hours where we're all coming together. I think we had almost 20 people at our last hacky hour, Central Machine Work, where we have our laptops open, we're eating some pizza, grabbing a beer, whatever, supporting our local establishments, getting to know each other in person, and hacking on things. There will be some contests and prizes in the next one. I think we're going to be starting to focus on controlling personally identifiable information and seeing what we can bubble up and get that knowledge base into the community here in Central Texas and Austin, leveraging LangChain and other AI middleware projects. So again, I want to thank each and every one of you for being part of our community, for contributing to the conversation, and very much so I want to thank Ricky and Kareem for their efforts in generating their talks in their labs, as well as being great core members of our community here. So on that note, I'm going to go ahead and wrap this up. Thank you, and we'll see you virtually on the next virtual one, or hopefully we'll see you physically here in Austin. We'll have a great time doing it. Thanks all. Bye-bye.
Thank you.
Thanks, everyone.